My name is Paul Galata. I'm a senior technology specialist with Mauser Electronics, and with me today is my special guest.
My name is Scott Kleinle. I'm the General Manager of Commercial Industrial for Amphenol.
Today, we're going to have a discussion about industrial Ethernet, SinglePair Ethernet, or SPE. Scott, there's a tremendous explosion of devices that are getting hooked up and connected into the Internet of Things, particularly in the industrial space. Tell me what you see going on there.
The old adage is to improve it, you got to measure it first. So we're seeing just an explosion of whether it's sensors, cameras, actuators, typically, all throughout the factory.
And that's really making this thing, this convergence that we've heard about, this industrial revolution called Industry 4.0. What does that all entail?
Yeah, so it's about getting more value out of your factory. So whether that is making your factory more efficient, understanding when your equipment needs repair, for instance, making sure that your equipment is operational, or even monitoring any process via camera or sensor throughout your factory.
Well, we're talking about industrial Ethernet, but there's a bunch of other protocols that exist. Could you share with me a little bit about some of those existing protocols and where we stand?
Yeah, one of the real things between SPE that we're trying to accomplish is making a single protocol for the factory. And so SPE, obviously the E in SPE is Ethernet, and it's really about driving Ethernet and Ethernet speed and connectivity to that sensor, actuator, or the quality camera at the edge of the factory.
I'm familiar with Ethernet that it often involves 4-pair, but with this coming of SPE, the single pair, we've reduced that down. Tell me about how that came to be and what drove that and the reasons behind it.
Yeah, you can almost think of those products together. So the IX industrial solution is 4-pair and would replace traditional 4-pair modular jack solutions. SPE is just what it sounds like, single pair Ethernet. So it's a single pair that you would drive to a camera or a sensor, but it's reduced cable bulk. It's a single pair, and it tighter bends to be able to be more flexible in applications in smaller spaces. And it really is attuned to those smaller devices like a sensor, where a single pair is just much more flexible, much easier to utilize for those types of applications.
Now, if my understanding is correct, this SPE as a standardization has really come about recently. And my understanding is that Amphenol's really been a big part of that you're part of this Ethernet Alliance and help bring those type of specifications and standardizations to bear. Could you share a little bit about that?
Yeah, so SPE, there's a consortium called the SPE Consortium. As of today, there's around 50 members. And not all those members are connector manufacturers. You have magnetics and silicon, other types of contributors to that ecosystem. But it's about 50 members strong. So it's a well-supported, well-established consortium with momentum.
That's wonderful. And so you said that SPE really connects devices that are out there at the edge so that we can get the information back into the cloud. So some of these devices are things like sensors and vision cameras and those type of things way out there on the front edge. Could you talk a little bit about how SPE connects that and brings those type of external sensing devices and captures their data?
Yeah, so when you think about SPE, one of the quick things you want to think about is plug and play. So that's really helpful for any integrator or installers to have a plug-and-play device. The other really important thing to think about is cloud to sensor. How do I get the data from that sensor or device or camera and get it to the cloud, make it more usable in real time without latency? And so SPE, with the speed and with the physical size, reduced bulk, saves a lot of money, but gets the data to the cloud all on an Ethernet protocol.
Now, I'm familiar with things like PoE, power over Ethernet, which is an important characteristic where we can get power into the Ethernet protocol. But my understanding is for the single pair approach, there's something related but different, something PODL or power over data line, poodle,
Yep.
as it's often referred to. Can you share a little bit about how that's different or in what ways it's the same or different than PoE?
Yeah, so Poodle is using a single pair to transmit both high speed and data over that single pair. And so for the single pair Ethernet, there's a specific specification, 802.3 BU, and that is specific to the Poodle specification, using a single pair to transmit both the high speed signal and the power all at the same time.
So could you share a little bit about how much power you're able to do? What kind of wattage and what type of amperage or current can you do in this Poodle configuration?
Yeah, so it's 50 watts and 4 amps.
Okay.
Yeah, so quite a bit. It's amazing. And the speed, when you think about the speed, it is 1 gig or 1,000 base T to 40 meters, and it's 10 megabits to a kilometer.
Wow, that's impressive. So what you're telling me that you're able to do is collect tons of information over short distances, enabling things like vision, cameras, sensors in cars, and those type of things, but as well as in a slower approach, but over a very, very long distance to be able to get that data back up to wherever you're collecting and collating it. And so that really offers a tremendous explosion to how many things you can connect into the whole system.
Absolutely. And so one of the big things is not only has it reduced cable bulk and added bend radius and flexibility, but each device, and let's face it, there's more and more sensors in the world, and there's more and more vision cameras in the world. They all take speed and bandwidth, but each one of those devices wants to be powered by that singular cable rather than having a secondary power source. So having single pair Ethernet do both the highest speed and power the device is an unbelievable value to the integrator or operations individual at the factory.
I think there's many unique characteristics about how you put together an SPE connector. Could you share with us a little bit about its form factor, its sizing, and what all is involved in how it's constructed?
Yeah, so a couple of things. SPE, obviously being just a single pair, it's going to be fairly small, and it really works well with some of the edge devices that we're talking about. Whether it's just small sensors or vision cameras, size matters. In this case, the small size really fits those types of devices typically, and I say it's at the edge, it can be anywhere in the factory. The other thing that I think that's really important is we have a couple different IP ratings or ingress protection ratings. One is IP20, which is really just touch-proof, and then we have the full IP67, which is both dust and moisture compliant. And so when you think about a factory, and certainly a factory that's existed 10, 20, 30 years, there's a lot of dust. Even the cleanest factories, you're going to have dust and other type of material in that factory. So having an IP67 solution that's both dust and moisture compliant for these devices is something really powerful.
That's awesome. One of the things that I heard you talk about when we talked about SPE is the speeds that we can do over these short distances. But one of the other benefits that I've heard about this technology is it also reduces cost. Because we have this proliferation and explosion of sensors and things we're measuring, it's lower cost to provide just a single pair. Could you share a little bit about just some of the orders of magnitude and the reasons why that's really compelling to people to try to move towards SPE?
Yeah, it's not often that you get a win-win-win. Higher speed, more power, and you're saving money. And that saving money is reduced cable bulk. And really, that's really, really important rather than having all of these wires. And one of the things we talked about a little bit earlier was in at least over time working towards a single protocol, you're getting rid of these protocol conversions, which are timely, costly, and possibly add error into your factory. By going to a single protocol, you reduce cabling, you reduce complexity, and you just make sure that it's going to work on that single protocol.
Scott, share with me a little bit about field terminations, the ability to take a specific SKU or product that exists, but to be able maybe at the system integrator level to make a custom, something tailored for a specific application.
We talked about 1,000 base T or a gig performance to 40 meters and 10 meg to a kilometer. We have a lot of cables, and we're very much willing to make any cable size that you want. But a lot of times, an integrator or installer in a factory, they're going to want to do a field termination to make sure that it's absolutely custom to where that specific piece of equipment is located in the factory. And for that, SPE is field terminable. And so that integrator or installer can terminate that cable right where the device is, right where the manufacturing equipment is.
We talked about the Ethernet Alliance and how you're part of that and help to build this standardization. Talk about multi-sourcing, about how that helps engineers recognizing that this product in its standardized form then allows them the compatibility to plug into various solutions.
Yeah, so SPE is definitely, through the consortium, going to be multi-source, available from numerous vendors. And of course, that is really what anybody who is trying to implement something really wants. They want the ability to not only upgrade the speed and the power today, but they also want to have the ability to get it from multiple suppliers so that they're good today and in the future. And so when you think about the SPE, think about it as a standard device. But one of the benefits from Amphenol, we're a global company. We can also provide custom cable lengths and custom solutions that still use the SPE solution, but get you exactly what you need.
You mentioned high speed out at the edge. I think important for our customers is to understand that we want to protect and block against noise. So my understanding is that a lot of thought has gone into protecting these SPEs against EMI and noise issues. Could you address that a little bit and tell what your company and what the industry has done to protect against EMI?
Yeah, so the SPE solution is fully shielded, 360 degrees shielded. So it's really put a lot of thought into the design of the connector to make sure that it is shielded in 360 degrees.
Scott, I know that SPE comes in a couple different form factors. Could you talk to me a little bit about right angle and vertical and what that all means and how those came together?
Sure. So we're trying to give the designer all the options so that they have everything in their toolbox. So with SPE, the board side connector, vertical, right angle. As I mentioned previously, it's in the IP20, which is touch-proof, and the IP67, that is dust and moisture compliant. You'll notice the latching. So again, the latching here is going to be tailored for industrial applications so that it's not snag-proof. So if you'll notice the push to engage and disengage the SPE cable from the board receptacle, both vertical and right angle, and then in the IP67, it's a IEC M12 form factor that is push-pull.
So what you've taken then is an industry standard, this IP67, something that's really water resistant, and made it with this push-pull so that nothing can ingress on it. It makes it very, very reliable and robust against harsh environments.
Yeah, super easy. It's a known form factor, that M12 exterior shell, and then in a push-pull makes it super easy to engage or disengage, but keeps everything protected both from dust and moisture.
Is there anything additional you'd like to share with our engineers about SPE?
So Paul, SPE really addresses all that the designer is really looking to address: higher speeds, power over the data line, protection from dust and moisture compliance, a latch that won't snag and break. Think about plug and play and going sensor to the cloud with that data. It's really exciting.
Thank you for all that information. I want to thank my guest, Scott, today for informing us about SPE. Please join us at our next Plugged In episode.